Hello guys, in this video we'll be discussing about the evaluation functions. So what is evaluation function? Evaluation function is nothing but we will be determining the level it has or the positions in the game tree, or the what we'll say we'll be saying the we'll be try to calculate each and every value of a level when go on increasing in the game. Whereas coming to a bubble shoot, when you go on increasing the level 1, level 2, level 3, so you will be getting coins, right? So that is what one of the evaluation function also. So based on your level and based on your progress, you will be determining the value of your winning or losing. So that is what evaluation function says. So in evaluation function we will also deal with the heuristic, because evaluation function is also known as heuristic evaluation. And in this video I will explain heuristic function full theory part, and later I will explain the heuristic evaluation, how it will be done in each and every step by taking an example. So let me write what's today's topic. Evaluation function. So what is an evaluation function? I already told that it also known as the heuristic evaluation. So an evaluation function is also known as heuristic evaluation function or static evaluation function. So don't get any confused between the heuristic evaluation function or evaluation function or static evaluation function. They are all mean same. So is a function used by game playing computer programs to estimate the value of a value or goodness. So whether you lose or win, so that will be calculating the evaluation function, goodness of a position in a game tree. So whereas when you take a chessboard, when you try to move your pawns, so what will happen? You will be trying to increase your winning or losing based on our opponent. So that is why in every level or in every row and column wise, you will be trying to check the probability whether you win or you will be losing. So that is what we will be trying to estimate the value or the goodness of a position in a game tree. And do we calculate the evaluation function? We will be calculating the evaluation function in terms of n values. Because evaluation function is a scalar term, right? In scalar term, what we'll be doing, we'll be dealing with the n terms only. So the value is quantized scalar, often in nth of the values. So we'll be calculating the values in the nth of the values, nth position, so that 2 power n, 3 power n, 4 power n. So in that way we'll be calculating the evaluation functions. So a tree of a such evaluation is already part of a min-max or any such algorithm. So how do we calculate the evaluation functions? So based on the graphs or the in a game, we'll be trying to calculate the evaluation functions. So it might be a part of a tree, right? So a tree of search evaluation is usually a part of a min-max or related search paradigm. So it might be any of the evaluations. It is in a graph or min-max or any other graph. So what does the value represent here? The value represents nothing but it represents the probability of winning the game whether we expand from the node to the end of the game. So if you are staying in one particular node and if you want to move a step, so when you try to move on each and every step, what you are doing, you will be increasing your probability of winning, right? So let me write in that point also, the value is presumed to represent the relative probability of winning if the game tree were expanded from the node to the end of the game. So see, when you doesn't move your king from one position to another position, what will happen? King will be remaining in that position, and there will be a increase in the chance of opponent to conquer your king. So that's why when you have to move your steps so that you can have the probability of winning. So you'll be having a probability of winning. So in each and every step you will be trying to move. So what do you find from the above information as from the example? So there might be some relation between the search algorithm as well as the knowledge in the evaluation functions. So why there is a search algorithm, search relation? Because so in each and every step you will be trying to find the each and every possible path, so that you will be trying to conquer the opponent's king. As well as there is a knowledge in the evaluation function, because in each and every step you will be trying to increase your power, so that you will be more aggressive than your opponent team with a huge number of coins in your board. So there might be the there is a relation between search. So we need to find each and every possible path, right? Search and knowledge in the evaluation function. So we'll definitely find some knowledge in the evaluation functions when you go on dealing with the different moves. So what will happen when you're going to the deep and deep and deep, when you're trying to expand the entire tree, what will happen? You will be trying to reach the less near nodes first. Then you will be trying to make some changes based upon the factors, that is tactical factors, and based on that we will be going with the long horizon positions, that is whether to conquer the king or not. So if this is a soldier, and if the soldier want to go to the last row of opponent team, what you will do? So you will be going to each and every row present before the soldier. Then after reaching the last node, what will happen? The soldier power definitely increases. So that is what we are dealing with. So when you go on digging to the deeper, we'll be what we'll be doing, we'll be eliminating the nearer one, so that we can reach the origin part. So let me write in the statement 2. So deeper search favors less near term tactical factors and more suitable long origin positional methods in the evaluation. So what you to understand? So the when you take a soldier, so it will what you will do, it will be killing the nearest nodes, right? So when you take a nodes, it will be going in a L shape, so that you can jump from the another soldier or another camel or anything, so that you can kill the another person. So what we are trying to do here, so we'll be trying to attack the nearer one first, so that we can reach the end node. So that is our targeted point. So deeper search focus on less near terms. So less near terms are the nothing but the less near nodes. We'll be first evaluating the less near nodes, so then on we can find the path which is the perfect path, so that we can reduce our cost. So that is what is. So tactical factors and motion. So for a long horizontal portion, so for example, taking a example of coming from Vijayawada to our campus, but there are multiple ways we can come from the rail or bus or bike, or by walk also we can come. So based on upon all the paths, what you will use, you will be choosing a train or bus. because in train we'll be taking around 300 kilometers. For bus it is around 315 around kilometers. So based on your path as well as the cost durations, you'll be trying to decide which path I have to make sure. So I will explain in example also. So I hope till now it is clear. So let us discuss some more points about the evaluation functions. So the what is happening here, so we have to calculate the efficiency and the cost and the time required, so that the what we have to do, we have to encode into a knowledge and the computational knowledge. Because when I consider the Google Maps, what it will be showing, it will be showing the four paths, that is by car, bus and rail. So it will be dealing with the cost and the time taken to reach a one particular place. So there is an efficiency as well as the encoded knowledge in the symbols, as well as the computational knowledge represented by the computers. So that is in that case also evaluation function is working. So there is a there is also a trade-off or exchange, anything you can call it as trade-off or exchange between efficacy or efficiency of encoded knowledge and computational knowledge. So see, that is what we are doing. So there might be some exchange of knowledge between each and every positions when you're trying to. So when you take a Google navigation, when you move on, when you are in a bus and when you move from one place to another place, so the navigation bar also continues moving. So there is an efficient knowledge sharing between your GPS as well as Google servers. So in that case, it works. Till now I think everything is clear about the evaluation functions. So now let us discuss about the evaluation functions in heuristic. That is, so let us recap now. So what is evaluation function? Evaluation function is nothing but we'll be trying to find the goodness or the value for a particular level. That is what evaluation function is. So based on your depth as well as the knowledge you have, you will be trying to have the probability of winning or losing. So that is what we have seen here. So we'll be having nth positions of the value, and efficiency is calculated in nth positions, and we'll be trying to find the probability of winning when you try to reach to a particular origin level. So that is what so there is some relation between the search as well as the knowledge functions, because we are so many paths will be there. For example, when you are going from hostel to a after hostel to a class, so there are many ways that we can come to the come on from the hospital or come to the class from the prefab. So there are many different ways, so that we can evaluate the functions based on the distance we cover. So there means there might be some trade-off or the exchange between the encoded knowledge as a computer knowledge when you try to take the examples of a Google servers. So that is what about the evaluation functions. So now let us discuss about the evaluation functions in heuristic. So evaluation functions in heuristic. So what is heuristic search? Heuristic search is nothing but we will be trying to attempt to get an optimized solution, so by iterating to each and every level. So that is what the heuristic search refers. So in heuristic function, what we will be doing in heuristic function, so there are two types, that is heuristic search and heuristic function. So don't get confused. Heuristic search, what we will be doing, we will be trying to attempt to optimize the problem by iterating improving the solution based upon the given heuristic functions. So there will be a heuristic function which will be defining the question itself. So based on that heuristic function, we'll be trying to iterate to each and every level, so that we will be getting a optimal solution. So coming to the heuristic function is nothing but the rank. So rank to a particular node. So it will be it will be changing alternately in search algorithms and each branching step. So based on the available information, so that is another point. So I think hope you got the difference between what is heuristic search and heuristic function. So let me note down. So heuristic search, let me take 1 second. So what is heuristic search? I told you that heuristic search refers to a search strategy that attempts to optimize a problem by iteratively. So we have to iterate each and every step because it is following DFS. So by based on your each and every step, we'll be trying to calculate the best alternative path to reach from the start to the destination positions. Iteratively improving the solution based on given heuristic function. So based on given heuristic function, we'll be trying to get an optimal problem by iterating continuously. So we'll be using a backtracking also. So iterating so continuously, we'll be getting an optimized solution. That is what heuristic speaks about. So let us come to know about the heuristic function. What is heuristic functions? I said that is a nothing but the rank. So heuristic function. So heuristic function is nothing but the definition will be as it is a heuristic function is a function that ranks alternative in search algorithms at each branching step. So you will be having each heuristic function at each and every level. So I will take one standard example, so don't worry about heuristic search and heuristic function. I will take an example from the textbook itself. Step based on available information to decide which branch to follow. So that is what heuristic function says, that we will be trying to rank alternatively in the search algorithms at each and every step in a graph. So let me take the before example, that when you're trying to reach from Nojvidu to Vijayawada, Vijayawada, from Nojvidu to Vijayawada. So there are many places, Agiripalli, or you can go from Mailavaram, or you can go from Eluru. So from Nujviru you can go to Agirpalli, then Vijayawada. From Nujviru you can go to Eluru to Vijayawada. From Mailavaram you can go from Nujviru you can go from Mailavaram to Vijayawada. So there are many paths, So but the distance we have to check. It is, for example, if we consider it as a 10 km, it is a 5 km distance between Nujviru and Eluru, and it is for example it is 25 kilometers. And the path between the Agirpalli and Vijayawada might be, think that this is around 150 kilometers, and this is about 100 kilometers, and it is 50 kilometers. So consider, just take an example. So what is the best route possible here? So we have to calculate the best route, we have to add the distance between the initial as well as the final node. So let us do that. From Nojviru to BZA, it is 10 plus 150, which is results to 160 kilometers. From Nojviru to BZA, it is taking as Eluru as a common, will be having 5 plus 100, 105 km. From Nujviru to BZA, taking as Mailavaram as a center, will be getting around 75 kilometers. So in evaluation function, what it does means, so it will be dealing with each and every route. So it will be going to each and every node, and then it will be finding the best route possible. So in this case also, what we have done, we have seen the first one, second one, as well third one, and later we have decided that Nujviru to Mailavaram to BZA is the cheapest path. That is, it will be taking it will take less time to reach the Vijayawada. So this is what heuristic function and heuristic search defines. So I will explain the types of heuristic as well as the with an example, so that you will be getting a concept clear. So there are two types of heuristic functions. Types of heuristic. So there are two types. First one is admissible, and second one is non-admissible. What is admissible is nothing but we'll be underestimating the heuristic function. In non-admissible, what we'll be doing will be overestimating the heuristic function. So let me write that too. So non-admissible. So what is admissible? And in admissible, I have told that it underestimates the cost of reaching the goal, and it is generally a GOL, sorry, GOL, it's goal. So it underestimates, admissible, it will underestimate the heuristic function, that is nothing but the cost to reach in the goal. So it is mathematically defined that heuristic function is less than or equal to heuristic dash of n, that is underestimating. So we will be underestimating that. It's nothing but which will represent with the less symbol between the two heuristic functions. So coming to the non-admissible, non-admissible is nothing but overestimating. If it is underestimating, it is overestimating. So it is overestimating the overestimating cost of reaching the goal. It always overestimates the cost of reaching the goal. So what will be the mathematical representation? That is h of n greater than h dash of n. So there might be a overestimation that h dash of n, that is heuristic function, will be always greater than the function we will be getting. So let us take the one example so that you will be having a concept clear. So this is a standard example given in each and every textbook. So see, I will take different values, don't worry. So from different values you will be trying to get the concept clear. E, F and G. So this is a standard example. So I will take different values, so don't get worried. So it is 2, 2, 2, 4, 4, 3. Now let us take that. So here heuristic function of B given as 3, and here heuristic function of B given as 3. So let me take it as 4. So here it is 3, and heuristic function of F, it is given as h of F. Heuristic function of F is given as 4, and heuristic function of C, h of C is equal to 4, and heuristic function of D is equal to 5. So in exam also they will be giving a small graph with the heuristic functions, or in case if they, in the exam if they doesn't give that, so you can make the requirements. So let us solution. So what we have to do is that we have to find whether the possible route is a admissible or non-admissible path. So that is our requirement. So let us write the solution, that is h of B. What the heuristic function of B? So 4. So what is the heuristic function of C? Function of C is 4. What is heuristic function of D? Heuristic function of D is 5. So what is heuristic function of E? It is E. Heuristic function of E is 3, and heuristic function of F is 4. Oh sorry, I forgot to okay, J is our final step, so don't know it. So these are our heuristic functions. Now what we have to do, so the heuristic function to calculate the that is admissible or not non-admissible, so there is a generalized formula, that is we have to add the root path as well as the heuristic function. So we have to add the cost of reaching from one node to another node, that is one place to another place. We have to add the cost as well as the heuristic function to get the requirement. So that is what mathematically represent as f of n is equal to h of n, that is heuristic function of n, plus g of n, that is cost to reach one place to another node. So this is a mathematical representation to calculate each and every step. So let us calculate for B. So from node A, that is starting node, to reach B, what is the overall cost? You have to see from node A to node B. So what is the overall cost? So path cost is 2, that is g of n is 2, and what is h of n? Let me write in a formula, h of B plus g of B. So we have to place, what is h of B? H of B is 4. What is g of B? G of B is nothing but the path cost, that is 2. So therefore f of B is equal to 6. So this is how we will be trying to calculate the each and everything. So let us calculate for E also. So f of E. So what is f of E? F of E is nothing but the distance from the root node to the E positions. So h of E plus g of E. So what is h of e? H of e is given as 3 plus what is g of e? G of e is nothing but 2 plus 4. That is, so this is the path we are taking from A to B to E. So 2 plus 4 is 6. So what did we get? We get 7 f of e. So f of e as 7. So let us take for f of c. So coming to f of c is nothing but h of c plus g of c. What is h of c? H of c is given as 4. And what is g of c? G of c is nothing but from initial state to a particular state. What is the overall cost? 2. So f of c is equal to 6. So coming to the d, f of d is equal to h of d plus g of d. So what is h of d? H of d is given as 5, and what is the distance between the initial node as well as the d node is 2. That is 5 plus 2, which results to 7. So f of d is equal to 7. So what are the remaining left with us? So we have to calculate for f. So what is f of f is equal to h of f plus g of f. So what is h of f? H of f is given as 4 plus what is the path cost? 2 plus 4 plus 4, that is 4 plus 4 8 and 10. So f of f is given as, f of f we got as 10. So this is how we will be trying to represent. So we have to say that one particular node is admissible or not admissible, we have to consider one particular node. So let us take a b here, b node. So b what did we get? We got the value as 6. So but what is the heuristic function we have 4. So 4 is less than 6, right? So what is the heuristic function of 4? Heuristic function of b is 4. But what is the overall cost to reach initial node to the last node? That is 2 plus 4 plus 4 plus 4 plus 3. 4, 4, 8, 9, 10, 11, 12, 13. So 13 is 13 we got. So what is the heuristic function of b is 4, and 4 is always less than the distance we have taken. So that is 2 plus 4 6, 6 plus 4 10, 10 plus 2 is the final answer 3. So we have 13 as the result. So from here we can see that h of n is less than h dash of n. So what is this says about? It says about b is admissible, because its heuristic function is always less than the overall path cost, right? So that's why to reach from initial node to the end node. So that is why h dash of n is that is b is admissible. So let's take another one, that is for c. Let us take for c. What is the heuristic function of